Hello, meghdad again. I'm back with another rigging tutorial, this time inside of Unreal using Control Rig. I'm going to show you how we can set up a complete leg, including the foot, using a concept called reverse foot setup. So we are going to see what is reverse foot setup, why we need that, and how we can create that inside of Unreal. It's all about having all of the complex animations that we create on the foot to also affect the leg. Knowing that the leg setup is not just about lifting the foot and having the need to bend with it. The foot itself is supposed to have a lot of extra functionalities. And on top of that, we need to make sure that all of these functionalities on the foot that we create are also affecting the legs. To show you the end result of it, let me jump into Unreal, and you can see that I'm able to lift the foot and rotate the foot all within one controller. However, here I'm able to rotate the foot from the heel. Same functionality along the tip toe here. You can see that I'm having extra functionalities here. Using one attribute, I'm able to actually create a very nice foot step action for the foot. And on top of that, you can see that I'm able to rotate the foot from the inside of it as well as from the outside of it. So all of these are actually the things that we are going to learn how to create today using a concept called reverse foot setup. Before I get into my 3D software, I need to have a very quick review of what's the difference between inverse kinematic versus forward kinematic, because we are going to use IK setup in multiple places for our reverse foot setup. As we all know, in any given IK setup, it's the child that is responsible for controlling the behavior of the chain. It's specifically very useful when we are dealing with chains that are having only two joints, because in those situations we are able to maintain the size of the bone that connects these two joints without being worried about losing the volume or anything. So this is a very simple two joints FK setup. If I grab the parent and move it around or rotate it around, the entire bone is going to follow that. However, if I grab the child and move it around, you can see that technically I'm stretching the bone itself. So if a geometry was scanned to this bone, technically I was losing the volume of the geometry. And on top of that, if you pay attention here, the parent joint is not aware of what's happening on the bone itself. So even if the direction of the bone is changed, the parent's rotation is not changed whatsoever. As opposed to that, in an inverse kinematic setup, which I have here, if I grab the IK handle and move it around, you can see that the only thing that is changing is the direction of the bone, and the size of the bone is maintained. It's not stretching. And also you can see that the orientation of the parent is aware of what's happening inside of this chain. That's the beauty of inverse kinematic on a two joint setup. So we are going to use that to control our foot from multiple points using multiple IK handles. So to give you a very quick overview of how this reverse foot setup is made for this given leg, you can see that we are having these 5 joints. We call them the bind joints. Their job is just to deform the geometry. We are not going to use them for animation. What we are going to create is we are going to have 3 IK handles or IK setups. One for taking care of the leg and the other two to take care of the foot. One is going to be on the ankle, one is going to be on the ball, and the last one is going to be on the toe of the bind joints. And then when it's time to control them, like any other inverse kinematic, we are going to control them in inverse direction, meaning that the toe is going to affect the ball is going to affect the ankle, and the ankle is going to affect the entire leg. Hence the name reverse foot setup. We are going to create a chain of joints. Their job is just to drive these IKs. We call them driver joints, and we are going to parent these IKs to this reverse chain here that is responsible for controlling the foot as well as the leg. So let's directly jump into Unreal and see how we can create all of these using Control Rig. Okay, we are in Unreal now. Let's actually see how we can build all of those functionalities on this character. I'm going to start over. So first, let's see what we have in the skeletal mesh. I'm going to double click on it. We have the base joint that is acting as the root here or center of gravity here, the hip, the knee, ankle, ball, and toe. This is a typical naming convention for these 5 joints. You can see that we are having the right joints here as well, but we are not going to do anything with them for now in this tutorial. Also be aware that the orientation of these joints are properly taken care of. I can visually show that inside of Maya. So I have the local rotation axis of these bones turned on, so you can actually see the orientation of these joints are properly created. It's very crucial because eventually we are going to rely on the local rotation axes of these joints when we want to create those reverse chains. We are back in Unreal. Let's see what we have here. I'm going to ignore this control rig that I've made for you, and I'm going to start fresh. So the first step is always to create a control rig from our imported skeletal mesh. So I'm going to right click on it and create a control rig here. I'm going to name this one tutorial. Very well. I'm going to open it up and see what we have here. Very well. So the first thing that we need to take care of is the main parent here, which is the base spine joint. For that, I'm going to right click on the spine joint here and create a controller for it. I'm going to name this base spine controller. And then I'm going to connect my joint to this controller. Since this controller is going to be used for animation, I'm going to give it a proper shape. Because of the orientation of the joint itself, I'm going to rotate it 90 degrees in the x-axis, and I'm going to change the size of this controller to be something larger. Awesome. I'm going to compile and I'm going to grab it and drop it here, get its values, and I'm going to set base spine using this controller's transform values. I'm going to connect my execute output to my set node here, and I'm going to test the result and see if it's working. Moving it around, and it's moving the entire hierarchy for us. Perfect. All right, the next step is to build our IK setup for the leg, which is a typical IK setup that everybody is aware of. So let's create the basic IK. For the basic IK, we need to provide with it exactly 3 joints, which in this case are going to be the hip, the knee, and the ankle. And also, in order to control this IK, we need to have 2 controllers. One is going to be considered the IK handle. Its job is to control the leg from the ankle, and the other one is going to be controlling the direction of the bend that we see on the knee. So the first thing that I need to have is one IK handle to be exactly on the ankle of the foot. So for that, I'm going to create a new controller so I can visually see where that is. I'm going to name this left ankle IK. And just to be a little bit more consistent in terms of color coding, so I'm going to change the color of it to something like blue, and I'm going to change the size of it to something smaller. These are not controllers. We are not going to use them for animation, but rather to solve the IK setup. All right, so for creating the basic IK for the leg, we need to fill in all of these names here. This is going to be our hip. So left hip is going to be the first joint. Then the knee is going to be the second one. And lastly, the ankle is going to be the third joint that we need to provide with the basic IK node here. The next one is going to be the IK handle. I'm going to get that controller and I'm going to have it to act as the effector for the IK solver. And now if I connect my execution to this node as well, my IK setup is supposed to work. However, this is the knee pop that I'm referring to. It's only because it's missing that controller that defines the direction of the knee. We need to provide it here. I'm going to disconnect my IK setup for now, and we need to create a controller. In Unreal, it's much easier than Maya. We just need to create a controller on the knee to inherit the orientation of the knee. So I'm going to create a controller on the knee, and now you can see that if I just move it forward in one axis, respecting the plane that is made with these 3 joints of the leg, I'm actually not leaving that plane, I'm just pushing it forward. So that's actually how we can create an aim controller for the knee, borrowing the orientations directly from the knee joint. I just need to make sure that its default values are zeroed out. So currently, if I compile this rig, you can see that it will snap back to its original position where it actually originally was made. That's not what we want. I'm going to, again, push it forward, and I'm going to assume the current position, all of these offset values, to be its default value. So I'm going to right click on this controller and I'm going to set the offset transform from the current values. If you pay attention to these values, you can see that as soon as I do so, it's going to zero out those values. It's going to carry over all of those non-zero values to the offset value. And it's going to say that this is now considered the new default position for this controller. So if I compile this, you can see that it's going to stay in this position. Let's name this left knee aim control. And I'm going to bring it over and use it as the pole vector for my basic IK. Keep in mind that the only attribute that we care about on this aim controller is its positional values. I cannot directly connect the transform output to the pole vector, but rather I need to expand it and only grab its translational values or its positional values to drive the pole vector. Now, if I go back and connect my execution again to the basic IK, you can see that the knee won't pop anymore. The aim controller is now functional. And also, if I grab the IK handle and lift it up, you can see that the knee is technically only looking at that controller. All right, so things are properly created for the leg, and now it's time to create the extra 2 IK handles for the foot itself. This time we cannot use the basic IK node anymore because with the 2 new IK handles, we are only dealing with chains that are having 2 joints. In order to do that, we need to use a new node called CCD-IK. CCD-IK is able to create an IK solution or IK solver for any given number of joints in a chain. So the first IK solution that we're going to create is going from the ankle to the ball. So I'm going to select the ankle, then select the ball, and bring them over to create an array out of them. You can see that it will populate this list here with all of those names that I have selected. I can just directly connect it to the input of the CCD-IK. And this CCD-IK still needs to have an effector. Let's call it IK handle. The IK handle is going to be sitting on the ball. So I'm going to create a controller or use a controller to act as an IK handle for me. I'm going to immediately name this left ball IK. I'm going to drop it here, get its values, and then have it to act as an effector for the CCD-IK. Same thing for the other chain as well. So I'm going to create another CCD-IK. This time I need to have a handle on the toe. So I'm going to create a new controller on the toe, left toe IK, and read it to act as an effector for the CCD-IK, and this new IK is involving the ball and the toe. So I'm going to make a new array for them and connect it to the input of the new CCD-IK, and I'm going to connect all of them to my execution order. These are only there to help us to see the IK handles. I'm going to scale them down, and let's test it out and see if they're affecting the shoe. They are. And since these are all IK handles, I'm going to color code them to a color that are distinctive from the controllers. All right, so I have the 3 IK handles here. It's now time to create the reverse chain here to be able to move all of these together using the driver joints. So in Unreal, I'm going to create new sets of controllers to act as the driver hierarchy for these IK handles. I can select all of them together and create for all of them together. So new controller. I'm going to unparent them because eventually I'm going to reverse the order of hierarchy, and I'm going to also immediately change their shape to something smaller. And I'm going to also rename them. Naming is very important because eventually we are going to deal with plenty of objects that are sitting on top of each other. So let's say this is the left reverse ankle, left reverse ball, and left reverse toe. We just need to double check and make sure that their default value is set to 0. So I just need to freeze their transformational values by right-clicking on them and setting the offset transform from the current. I'm going to do the same thing for the toe. Set offset. And just for good measure, I'm going to do that for the ankle as well, although its values are set to 0. Now it's time to make the reverse hierarchy on these driver controllers. The toe is going to be the main parent, the ball is going to be the child of it, and then the ankle is going to be the last child. I'm able to rotate the toe controller. You can see that it's lifting the other 2 controllers. That's what I'm expecting to see. The only thing that I'm missing is making sure that those IK handles are following those respective reverse controllers. If the naming convention is correct, I can just look at the names and drop each one of the IK handles under their own reverse controller. So this is the ball IK handle, and this is the ankle IK handle, like that. Now if I grab the controller and rotate it up and so on, it's going to lift the entire foot for me. I can grab the reverse ball controller, and you can see that it's rotating the entire upper leg for me. So we made all of those reverse chains. However, we are still missing those extra pivot points for the inner side of the shoe, the outer side of the shoe, as well as the heel here, right? So we need to create 3 extra pivot points or 3 extra controllers here to act as pivot points for those rotational behaviors. So what I'm going to do is I'm going to create 3 new fresh controllers by probably creating them in the word space by right-clicking in this empty area and creating a new controller here, naming this first one the left reverse heel like this, and properly position that on the base or on the back of the shoe here. So let's go to the top view. Before that, I'm going to change the size of this so it's easier to see that. This is the controller. I'm going to grab it and place it exactly right on the back of the shoe. When I'm done, I need to also make sure that I'm having frozen values on the controller. So I'm going to right click on this and set the offset to current. The only thing that we also need to consider here is the orientation of this controller, because all the behaviors of the shoe are coming from the local orientation of these pivot points. In my case here, I'm a little bit lucky, so the foot is already aligned forward. However, just to demo how to solve that, let me show you how we can reorient this controller towards the tip of the shoe. The whole idea is we need to make sure that we have 0 values on the rotation values of the current attribute, and anything that is defining the orientation is happening in the offset. So in my situation, I can simply just rotate using the offset value here in hope that I can reorient this controller towards the end joint here. That's perfect. And you can now see that all of the other values are still set to 0. I will do the same thing for inner and outer side of the shoe. Let's call them bank. So let's start with the inner side. I'm going to move it over, freeze it by setting the offset from current. Let's name this one left inner bank and duplicate this, bring it over. You can see that I'm placing them right on the tip of the inner or outer side of the geometry. Freezing this, and this is my outer bank. For the inner and outer bank, the orientation is also very crucial. So I'm going to go to the offset and see if I need to reposition them or reorient them so they are looking at each other. And now it's time to make these reverse chains to be a part of these new anchor points that we just created. I will have the reverse toe to be directly a child of the heel, and the heel is going to be the child of the inner, and then the outer bank controller, right? Let's go back to the perspective view. We introduced these new anchor points for the foot. Now, if I grab the outer bank, you can see that I can rotate the entire foot from the outside. I can grab the inner bank, rotate it inward, and the heel is there to be able to lift the foot from the heel area. The rest of the setup is still functional. I can still rotate from the toe or rotate from the ball. Everything is interconnected with each other. And you can see that because of all of those IK setups, the leg is responding to all of these rotational functionalities. So technically we are done with this setup. We can start animating this foot using all of these controllers. However, as an animator, I would say that this setup is not animation friendly because we are dealing with plenty of controllers and plenty of attributes. Sometimes some of those controllers are only doing one thing and maybe rotating the toe from one axis. So how about we actually take care of controlling all of these controllers using one main controller that carries some extra custom attributes on it to take care of controllers that we just created. All right. In order to do that, we need to create a new actual animation-friendly controller for the foot. The placement of it is important. It's supposed to be in the same spot as the ankle because that's the anchor point that we're currently missing in the setup. So I'm going to right-click on the ankle and create a new controller. This time I do care about the shape of it because that's what I'm going to use for animation. So I'm going to make it a box shape. The only thing that I don't like about the visuals of this controller is it's tilted. It's okay if I go here in the offset tab here and zero out the rotational value that is causing it to be tilted. Also, I prefer to have the controller to be sitting on the ground. So I'm going to go to one of the side views and visually change the shape of this controller so it's sitting on the ground and also it's containing the entire foot geometry. Perfect. You can see that I'm only moving the shape of it. So the anchor point is still on the ankle. Let's name this left foot control. Now let's have the entire reverse chain to be a child of this. All good. Now if I grab the foot controller, I can lift the foot up. I can rotate the foot. And still all of those extra functionalities or anchor points are still functional here. The next thing that we are going to do is we are going to create some custom attributes on this main controller to take care of the rotation of these inner controllers. And at the end, we only want to see one controller controlling all of those pivot points for us. In order to do that, what I'm going to do is I'm going to define new animation channels. Anything that you see here that is animatable is called animation channel. So I'm going to start by creating an animation channel to drive the rotation of the outer bank. Eventually, I'm going to replace it with something else. I can read its values by getting this channel, and I can drive the rotation of the outer bank in the direction that I want. So I'm going to set the controller's rotation using this attribute. I'm going to create a new node called sequence that allows me to sequence all of these executions. So let's say the first element that is supposed to be executed is this one, then all of the IKs, and eventually all of those extra functionalities that I'm going to set up in a moment. Let's connect our forward solve to the input of the sequence. Let's also do some cleanup here before we proceed forward. And the next one is to rotate the outer bank's controller using one single attribute. Also, since I do not care about the positional value of this outer controller, how about we actually use a set rotation? I just need to convert this single value to a rotational value. So the node that I'm going to use is called from Euler. The only thing that I care about is X value here. And I'm going to connect the output of it to the rotation of my controller. All right. So double checking that this is the actual outer controller here. And I'm going to connect my sequence to this one. And I'm going to use this animation channel to drive the rotation of the outer value. So I'm going to rotate it by 40 degrees, 50 degrees, 60, and so on. However, although this is functional now, I need to create another attribute to drive the rotation of the inner controller, and eventually I need to make sure that I only rotate the outer controller in one direction and the inner controller in the other direction, and it's not that animation friendly. What we typically do is we are going to combine these two outer and inner banking into one attribute. Let's do that. I'm going to rename this one bank attribute. The idea is that if it's positive direction, it rotates the outer. If it's negative direction, it's rotate the inner one. All right, so let's actually drop it here, get the animation, and let's start by saying that if this attribute is from 0 to 10, for example, we need to rotate the outer controller from 0 to 90 degrees. So the node that I'm going to introduce here is called remap. So we are going to read the bank attribute here, and we are going to say if the value is 0 to, for example, 90, we want to map it to a value of 0 to 90, right? Or a banking could be from 0 to 10. It's up to us, the range that we want to define for this banking. We are going to drive the outer bank control like that. Let's try it out. The point here is that not only it's remapping this range to the output, but also we can turn on the clamp. So if it goes below 0, it only stops at 0 rotation. Even if we go beyond the value of 10 in the input, it only stops at 90 degrees. Now let's do the same thing for the inner controller. So I'm going to remap again our input. This time I'm interested in the negative direction. So any value from 0 to negative 10, I want the inner controller to rotate. Let's try that. Let's see. It seems that that is also positive 90 degrees. And making sure that the clamp checkbox is turned on for it. All right, so I'm going to grab the inner bank, rotate it in the positive direction. Let's test it out. I'm having one bank attribute that has both directions available. I can rotate it forward and I can rotate it backward. And now you can see that we are having some issues here. The problem here is that as soon as we, for example, start rotating the outer bank, it's also moving up the inner bank joint as well. And the problem here is that all of these set rotation nodes here are doing all of those rotations on these controllers in global space. So in order to solve all of these, on these extra functionalities, what we need to take care of is making sure that any kind of rotation that we define for them is happening in their local space. So any set rotation that I'm going to create from now on, I need to just make sure that they are set to their local space. I'm going to go back to my foot controller, positive direction, and it seems that negative direction is in the wrong direction. So let's actually take care of it by mapping the negative values of the bank to negative values of the rotation. Going back to the foot controller one more time, positive activates the outer, negative activates the inner. Let's do some cleanup here. Now let's take care of the other pivot points that we have defined. So I'm going to take care of the rotation of the heel. Let's create a new animation channel. Heel rotation X and heel rotation Y. So I'm going to grab the heel X first. I'm going to bring in the heel reverse controller, set its rotation, making sure that I'm doing everything in the local space. And we need to convert it from Euler to rotational parameter. And I can also take care of the rotation Y here as well at the same time. Just to have that freedom for animators, I'm going to make the rotation X available as well. I'm going to bring in the rotation Z as well, get its value, and we are going to connect each one of these axes to the rotation of the heel controller. This is the wrong node from Euler. Connect it to the rotation. Create a new sequence here. Like that. Compile. Now if I grab the controller and play with these, you can see that it's rotating the heel in all axes for me. All right, now let's take care of the toe, which is the next item in our hierarchy. We're going to do the same thing. So for the toe controllers, how about we just borrow these and duplicate them because they already come with those defined ranges. All right, I'm going to copy all of these. It's similar to the heel, so I'm going to just quickly do that. I'm going to grab the toe here, set rotation, immediately set it to local, and then connect the result to it. Here's the toe. Like that. I'm going to limit the toe rotation Z, so on the toe, I'm going to have the max to be 0. The last one is going to be the ball only in Z axis in negative direction. So let's create a new animation channel. Ball rotate Z. Give it some ranges here. So minimum of 90 degrees and maximum of 0. Rate its value. It was the Z axis for the ball. So I'm going to connect this to the Z. And let's grab the ball reverse controller, set its rotation to local value coming from this attribute. And now we have this extra attribute that allows us to rotate the ball. All right, I'm happy with the result. The only extra thing that I want to add to this is just to allow the animators to take care of a very nice foot roll effect on the foot without dealing with multiple attributes. I'm going to go to my original character rig here. So if I look at my attributes that I've created for this foot here, one attribute that I'm having here is called foot roll. And you can see that with the help of this attribute, I'm able to do multiple things at the same time. If I change the value to the negative values, it's going to rotate the heel upward. If I go towards the positive direction, it's going to first lift the foot from the ball area to some certain degree. And then after that, it's going to lift the foot from the toe area. And that allows us to create a very nice foot roll effect on the foot using one attribute. So let's see how we can do that. I need to create a new animation channel. I'm going to name this foot roll and derive the rotation of all of these controllers that we have. So we want to respect these and we want to add to them the effect of this foot roll controller. Let's first start with the simple one, which is lifting the heel in the positive direction. This is the reverse heel. I'm going to add to the rotation Y of it the positive values that I get from the foot roll. I'm reading the foot roll value. I'm going to clamp it to only be the positive values. So let's say if the foot roll is all the way to 90, it's going to lift the heel in this direction. I'm going to add this to the whatever value that is coming from that attribute that we just made for the heel rotation. So I'm going to add this and then drive the overall rotation of the heel. Now let's test it out. Let's go here. That's foot roll. I'm going to redefine the range for it just to make the sliders to be a little bit more useful. And now let's go positive directions. It seems that it's rotating the heel downward. Let's just multiply it by -1, so it's actually lifting it up. Let's try it one more time. Positive. It's lifting the heel up. So we took care of the positive values on it. The negative value is a little bit more tricky because we need to split it into two ranges. If it's between 0 to, let's say, 40, we want the ball to rotate first. And then if it's more than that, we need to add the toe rotation to it as well. What we need to do is we need to control the toe as well as the ball. In order to make it easier to follow the flow here, I'm not going to use this exact node and branch out one more time, but rather I'm going to create another instance of it. Let's take care of the rotation on the ball. Create a remap. We are in the negative direction, so anything between 0 to negative, let's say -20, is going to rotate the heel from 0 to, let's say, 30 or 40 degrees. And I'm going to add this to whatever I had on the original attribute on it. All right, let's test it out. We might need to reverse that direction too. Yeah, it's rotating it backward, so let's actually invert that direction. I'm going to multiply whatever value I get here by -1. I'm just changing the direction of the rotation. Negative, it's going to rotate it upward. The only thing that I need to double check is clamping the output just to make sure that it's not going beyond the value of 40. I can change this range to something a little bit larger to allow the ball of the toe to actually rotate even further. Let's say 60. All right. And after that, we want to actually bring in the toe rotation and continue the rotation. I can branch out using the same get foot roll attribute, or I can make another instance of it here. So get animation, remap, immediately clamp it. The value that we care about is anything beyond -20. So let's say minimum is -20 and maximum is -90. That's the range that I defined for this attribute. And I want the value here to be from 0 to, let's say, 90 degrees. And we're going to add it to current rotation of our controller. Going back to the foot roll, 0 to -20 is going to lift the foot from the ball. And beyond that, yes, we need to change the direction here. We can actually do that within the remap node itself. So remap it to 0 to -90 degrees. 0 to -20 and then -20 to 90. Like that. So positive, heel, negative, two joints at the same time. Things are now functional, and let's do some cleanup here. Okay, so I'm gonna grab the new control rig that we just made, drop it here in the scene. You can see that all of those channel boxes that we have created are showing up here. I'm going to also reset its position to the origin. Now let's grab the controller and see if things are working. It seems that they are. All right, and now let's test the attributes that we have made. It seems that the banking is working. The one that I'm interested in is the foot roll. Perfect. All right. So in the sequencer, they're showing up here. So let's actually reset everything to 0 values. I want to show you something that is still missing here. So how about I start, for example, lifting the foot up. Here's the foot controller. I'm going to animate the location or transform values of it. I'm going to lift it up. And then I'm going to animate the foot roll, for example. That's the foot roll. So you will see that it's actually not respecting those animations that I have on it. It's either snappy or it's not even doing anything. And it's only because we are having multiple things happening at the same time, some rotation controllers, some actual IK handles. They sometimes compete with each other. Sequencer doesn't know which one it's supposed to actually execute first. We need to tell sequencer which one of these controllers are actually used for animation and which one of them are only there for containing information. So in order to solve that, what we need to do is we need to turn these controllers that we already have attributes to control them into things that are not made for animation, but rather for visual purposes. So in order to do that, we need to go back to our control rig, and any controller that is not meant for manually animating, including the IK handles, and on the right panel in the details, we need to change their type to visual cues. This means that they are no longer going to show up in the sequencer, and it means that sequencer is not going to be confused anymore as to whether they are meant for animation or not. While I'm here, I'm also going to turn their visibility off altogether. So again, the animator is not confused as to what they are supposed to actually grab and animate. All right, now let's go back here. You can see that those controllers are no longer showing up here and things are much cleaner, and we are not having that issue that we actually had. So the foot roll is functional. I can go negative direction, and you can see that it's giving this very nice foot roll effect altogether. All right, so we just made a complete leg setup, including the foot, using the reverse foot setup technique. I just covered everything that is required to be able to set up the leg, as well as making it ready for sequencer to be able to animate that. The other leg is similar to this one. So whatever we just learned for the left leg and the left foot is going to be similar for the right side. Just make sure that you are aware of the joint orientation, phrasing the transformations, having 0 values on the controllers that you make, as well as making sure that if you are creating those extra functionalities, they're supposed to happen in local space and not in the global space. And at the end, make sure that you make your controllers visual cue type controllers. So in sequencer, they are not actually confusing sequencer in terms of the sequence of executing those functionalities. So that's about it. This is called a reverse foot setup. And I hope that I can see you again with another video tutorial inside of Unreal using control rig.